So net configuration will use the XML encoding for managing the configuration data as well as the state data. So let us understand the code line by line, so that become easy for everyone to correlate with it and can understand it in a better manner. Now the first line what we say is a less than question mark XML version is equal to within quotes 1.0, encoding is equal to within quotes UTF-8, then question mark and then the symbol, closing symbol. Now this line is called as a prologue section of the XML. It's the very first line always written in the top of the XML document. Now version, there are two versions of the XML, 1.0 and 1.1. So we can use either one of them. An encoding scheme has to be specified. Now there are various kind of encoding scheme. For example, we have got UTF-8, UTF-16, UTF-32. And UTF stands for Universal Character Set Transformation Format. Now, if you look at this format, how did it evolve or how did it came into being? If you take C and C++ programming language as an example, both of them are byte oriented. They supports 8-bit, right? Java is Unicode based, 16-bit. But as of now, XML is the only language that is 32-bit. The character set is 32-bit in size. And the character set is called as a UCS, Universal Character Set. Now, if I want to send or transmit or share the data between the devices that supports variable formats, then I have to use one of the best encoding schemes. So to start off, we use the UTF-8, means the encoding scheme is universal character set based, called as universal character set transformation format, and that supports 8-bit encoding. That is what UTF-8 is. Then the second line specifies the DTD. DTD is a declaration type document. Now we can design the XML document in two types. One is without DTD and one is with DTD. Once you design the XML without the DTD, it is called as a well-formed XML document if your syntax conforms to the rules and specification of the XML parser and interpreter. However, if you write a DTD in your document type declaration, then it is called as a valid document. So valid document is a well-formed XML document plus with one which has a DTD inside it, because it's not necessary that you declare the DTD inside your XML document. But if you do it, then it is called as a well-formed and the valid XML document. Now here it starts with the doc type. So doc type, and then we give the name as sensor, right? That's the name of the DTD document type declaration which we are specifying in our XML document. Then the opening square brackets, and where it will close down on the line number 11, the closing square brackets. Now I can define multiple entities and elements within my DTD. So what is the syntax? Again, less than symbol, exclamation mark. I define the entity. NBSP. NBSP is a insert the blank space. So NBSP. Then is a writer. You can write your name, the person who creates the XML document. Then we have got copyright. Then any of the lab, the company, the corporate sector who will hold the copyright for that particular document. Then SSH is for the secure shell. Now here I say secure shell should have certain tags inside it. So I need to specify what kind of tag the secure shell will have. So I specify name, protocol, port number and the device. All of them are specified within the parenthesis. And then I close down the tag. Then I take every element one by one individually. And I say in the line number 7, I take the element as name. Now which name it is it this name? And I say whenever the user, user here is the developer or the programmer. Whenever he will enter the data type will be the PC data. PC data is a parsable character data. And how do we write the code? Within parentheses hash PC data. That is the way how we specify it. Now that can include the strings, the number, integer, float, byte, boolean, any kind of data comes into the under the category of the PC data. Then I specify the protocol for this net configuration. And again, it is going to be of the type PC data, the parsable character data. Then the port number, we know net configuration uses the port number, uses the RPC protocol, and the RPC protocol uses the port number 111. So port hash PC data. Then the device, and then again hash PC data. So I specify the configuration state with the help of the DTD in the XML document, and this will always be specified at the start of the document. Now there are two ways how I can specify DTD, one internal to the XML document, one external to the XML document. I can extract the DTD from here, create a separate file, let's say called sensor.dtd, and then I archive my XML document as well as the DTD document at the same location on my system. So I can have the external DTD also. But in this current program, I am using the internal DTD, where the XML code and the DTD code is all within the single XML file. Now, this is the way we write the comment entries. So less than symbol, exclamation, hyphen, hyphen, and then your entire statement will come. Then again hyphen, hyphen, and the closing tag. Then we come to line number 13, the secure shell, and we specify the name. Now here we are doing for the net configuration. So we specify netconf, and then this is the opening tag for the name, and this is the closing tag for it. So those of you who are new to it, how do we differentiate? In the closing tag, we specify the forward slash within the angular brackets. In the opening tag, we don't do that. So this is the opening tag, this is the closing tag for the name. And between that, we can specify the data. This is the data net configuration. Now this net configuration will use a protocol called RPC. So we define a tag by the name protocol. Now this should exist within the DTD. So DTD will specify the validation part. Means it's just like a forward declaration. What you do in the C and C++ programming, it's more like that only. So I specify protocol, and then I specify the RPC remote procedure call based, and then the closing of the protocol tag. Then RPC use the port number 111. So opening of the port number, we specify the data, and then the closing of the port number. So here what we are doing, we are defining a tag, the child tags within the root tag. What is the root tag? Secure shell. So this is the first tag to open in the XML document, and with the last tag to close down the XML document, the root tag. And every XML document can have only one and only one root tag. But yes, we can have multiple number of the parent and the child tag within the root tag. Now I said device can have multiple child tags inside it. So what I do, I create a child tag called the sensor1 on the line number 18 under the parent category of the device tag. Now I specify the who is a vendor who is carrying out the deployment of the sensors for the IoT network. So we specify vendor, and then I specify the name of the lab, the Swinger lab, and then the closing down of the vendor. So the vendor, this is a lab which is carrying out the IoT based experiment. Now the lab looks something like this. This is the lab, Security Wireless IoT Network Group of Engineering and Research Lab. So all the IoT based experiment, the latest work on the ship network, IoT, web accessibility, cloud computing, blockchain technology, quantum computing, we all carry out under this lab only. So when I say vendor, I am referring to this lab. So this will have the copyright also, as well as the rights to install the sensors on the specified IoT network, where the dimension will be specified. So I specify the name of my lab, and then I give the ID of the device. Now we know all the devices will have their MAC address or the physical addresses. They're almost all 48-bit wide. So we give the 6-byte MAC address of the device in the ID part. Then for what purpose I am using this sensor? So I am using it for soil base. So name becomes soil. I will specify soil within the name tag. Now where I carry out the deployment of this sensor. So I need to specify the location. So I specify the region, the district, which is Barmer district of Rajasthan. Then what are the latitude and the longitude of that specific location where sensor will be installed or deployed. So I specify the coordinate latitude, lat and the long coordinate, latitude, degree times north, then 71.382 degree times east. So I specify the latitude and the longitude coordinate where the exact location where the soil specific sensor will be deployed. Then what is the sensing range and what is the communication range of this sensor? Now since we are doing a long range communication, so sensing range is kept as 15 meters. And the communication range for the sensor is also kept as same as a 15 meter. Having done that, so this is all the state data. Earlier part was the configuration data. Now I'm all specifying the state data using a net configuration protocol. Then on the line number 29, I close down the deployment tag, which has started in the line number 22, right? And then we close down the information for the first sensor. So sensor 1 is closed down now, which was started on the line number 18. It has got closed on the line number 30. Now we start with the sensor 2, the second sensor. So net configuration remains same, the RPC remains the same, the port number remains the same. So all these three things are applicable to both the sensors because they are declared above the device tag. Now we come to the sensor 2. So first of all, closing of the sensor 1 and then the starting of the sensor 2 tag. Again, I specify the vendor, the name of the company who is owning these sensors. So I specify the name, I create a vendor tag, opening and closing, and then I specify the name of the company. Then I specify the ID of the sensor. Again, it's a 48-bit MAC address. So we specify 8 bytes information. Then now this time the sensor is a temperature oriented sensor, temperature based sensor. And I carry out the deployment in the hilly region. So where do we go? To Shimla, or we can go to Uttarakhand region, any region where hills are there. So I specify the region, the district, the Shimla. I trap the latitude and the longitude coordinates. So north and the east, the lat and the long coordinate are specified where the actual deployment of the sensor will take place. Now on the mountainous range, we can't have a long-term range because we know it's easier to set up the deployment of the IoT network on the flat bed terrain as compared to the mountainous terrain. Mountainous terrain is all uneven. It's a hilly terrain. We all would have seen it. So deployment of the sensor itself is a challenge. It's difficult, and we can't have a long range communication because of the uneven terrain of the mountain. Also, the sensors are very vulnerable to natural calamities when you carry out the deployment of the sensors on the mountainous range, because we can have the flash floods, the landslides, the earthquakes, the cloud burst. Various kind of natural calamity can occur that can result in the wear and tear of the sensor and can also physically damage the sensors. So they need to be replaced out. They need to be replaced with a new sensor. So carrying out a deployment of the sensors on a mountain is always a challenge. We can have the extreme snowfall, especially in the winter seasons. So again, the sensors need to be replaced, and the experiment need to be time bound. We can't have an experiment running for the entire 12 months. So we need to identify when we need to carry out the deployment of the sensor so that the experiment can be successfully committed. So we always go for short range communication based sensors, roughly ranging from 1 meter to 5 meter. So we always keep sensing range and the communication range almost as same. Then we close the deployment tag of the XML document for the net configuration. Then we close on the sensor 2 tag, and then we close on the device tag. In this way, I can create as many number of tags for a sensor. I can have 50 sensors, 100 sensors, 200 sensors. So I need to specify the location and the latitude and the longitude coordinate for every sensor, where it will be positioned on the land or on the lab or on the mountainous region or on the ocean seabeds or on the rivers, wherever I'm going to carry out the IoT experiment. Then I close on the secure shell, so SSH. So SSH will be the last shell. Because if you look here on the line number 13, we start with the secure shell for the net configuration. So the last tag which will be closed on this XML document will be with this root tag only, under which all information for the net configuration has been done. And why we did it? Because net configuration uses the XML and uses the RPC protocol for dealing with the configuration and the state data, which is going to be shared between the IoT devices. Now I need to execute my XML code. So what do I do? One option is that I can deploy my XML code. I can execute my XML code in the web browsers which supports the XML language, means XML compliant web browsers. And nowadays almost all the web browsers are XML compliant. So you take Internet Explorer, Netscape Navigator, Mozilla Firefox, any kind of the web browser, they're all smart. They all understand what the XML language is. Other option is I can go to the online utility or online tool, something like this. Yeah. Now here we can see the same code which I just discussed. So I have opened it into the codebeautify.org XML viewer document. It's the same code which I just discussed. I copied the code and I just printed it here, right? So I can run my document and I can see here the tree on the right hand side, which has been created by the XML viewer. Now this tree will be created once your entire code is right. If there are certain bugs in the code, so let's say you opened certain tags but you have not closed them down, or certain tag information is missing, or your XML data here starting from the line number 12 to the last line is not following the DTD which have been specified on the line number 2 to 10. So your data here, whatever data you write, should follow the rules and regulation which you have specified within your DTD. So DTD will make sure that you follow it. Otherwise, the document will become invalid XML document and you won't be able to see this kind of the tree on your XML viewer. So you can see here secure socket shell, net configuration, protocol is RFC, port number is 111, device, sensor. You can expand or compress it as per your requirement. So if you want to have the information about a specific sensor, you can click on the plus button, expand it, and it will show the information of vendor, ID, the name, the deployment, region, latitude, longitude, sensing range, communication range, and then you can expand sensor 2 to see more information about the XML tree which has got generated. So vendor name, ID, name, deployment, region, latitude, longitude, sensing range, and so on and so forth. So this is how the result get displayed by the XML viewer. Now, if I want to have the conversion to JSON, what we call JavaScript object notation, so I can click on this button called XML to JSON, uh, and I can generate the JSON code for it. A small simple code. So using the same XML document, I can have my JSON format ready. So secure socket shell, the name, protocol, port, device. So from the line number 7 to line number 18, I have got information for sensor 1. And we all know JSON supports curly braces. All data will come into the curly braces. And you will have this attributes here with the corresponding values separated by column. And this attributes will be within the quotation marks. Same way we can have sensor 2 with all the attributes within the quotation mark, followed by colon, followed by the actual value of it. So I can easily generate the XML document. I can have the XML document for the net configuration protocol, and I can generate the JSON file for it. And then I can carry out the deployment of it on the server side. Or I can also export to the CSV file, the comma separated value file. So the file will get downloaded onto my machine. So I can even have the data in the CSV file, comma separated value file. So that's the easiest way. How do we do it? Check the XML document whether it's fine or not. If everything is fine, then it will generate the XML tree like structure which is here. And if there are certain errors committed, the wrong code has been done, the tags are not properly placed, tags are opened but not closed, or there is a spelling mistake in the opening and the closing of the tag, immediately it will throw the error and it will not generate the XML tree structure. Now what can I can do is I can convert my XML code to YAML language also. So here, if you look at this tool, XML to YAML converter lets you convert your XML to YAML online. So select the XML file or load the XML file from the URL or enter the XML data and convert into the YAML language. So I can my SNMP, my net configuration and the Yang. Yang will just discuss it afterwards after the net configuration, and the YAML language code can easily be used here. So let me use the same code which we just discussed, and I go to I enter the XML code here. The XML code is there, and I can convert. Yeah, I click on the convert and I can see the result here. The simple YAML code is available here with no curly braces. We'll just see the name of the attributes followed by colon followed by the corresponding value. The attribute colon and the value, attribute colon and the value. So will not be able to see what is DTD here explicitly. Though DTD has been enforced, it is still working it's still in motion. But the word DTD will not be written here. No doc type will be seen in the YAML language. So port number, device, sensor one, vendor, colon within ports, the name of the vendor, ID, name, deployment, region, latitude, longitude, sensing and communication range, then the sensor 2 and all the information about the sensor 2 like vendor, ID, name, deployment, and the information about the sensor 2, the region, the latitude, longitude, sensing range, and the communication range. That's how the code gets converted into the JSON language. For the net configuration, I can convert into a CSV format. I can convert into the YAML language, depending on my choice. But I need to design the XML document first for a given net configuration protocol. Means the information about the sensor need to be available with me first, and then only I can specify the XML doc. I can specify the tags of the XML document. I can identify that what is the right tag and what is the data to be loaded in those tags in my XML document, and thereafter I can carry out the conversions to the JSON or to the CSV or to the YAML.